Today our lesson is going to cover the topic of multiplying polynomials. Please remember that polynomials are expressions that primarily are a combination of various terms with either addition or subtraction. I want to look at exercise 1 and look at this polynomial, and I want to try and make a connection with our base 10 number system. So we're going to look at 2x cubed plus 5x squared plus 3x plus 4, and I would like you to evaluate it when the value of x is 10. I'm going to give you a moment to do that. I want you to first try to do this mentally and only use a calculator if you absolutely need to. Now, I want you to look and remember I've got x cubed as part of the first term. Think about what that means. X cubed is 10 cubed, and using our base 10 number system we should know that 10 to the third is 1000. Likewise, x squared is 10 to the second power, which of course is 100, and x alone of course is 10. So if we think about combining this, we really have 2 times 1000. We're going to add to that 5 times 100. We're going to add to that 3 times our 10, and then we have a constant as well to add in, and that is 4. If we think of it this way, we end up having 2000 plus 500 plus 30 plus 4. And if we put that together, we end up with 2,534. And that is what I'm hoping you came up with when you evaluated that. Again, the idea here is to see how our final total, 2,534, actually came from a combination of 4 pieces being added together, and that was based on the base 10 system. This is what allows us to take individual terms and break them up into pieces and yet combine them for a final answer. Let's look at how we do this when we have binomials, and we're not going to evaluate for a specific value. So let's consider the product of 3x plus 2 with 2x plus 5. Remember, product, of course, meaning multiplication. So I am going to start by writing down my two binomials. And I'm going to use the double distributive property, meaning I'm going to distribute twice. I am going to start by taking the 3x from the first binomial, and I am going to multiply it by the entire second binomial, 2x plus 5. Then I'm going to take the second part of the first binomial, the second term, which is plus 2, and I am going to multiply that as well by the entire second binomial, 2x plus 5. After this, I'm going to do what we consider our regular distributive property. Please be careful to include the sign when you're on the second part of this. And I end up with 6x squared plus 15x plus 4x plus 10. I, of course, go through and I combine my like terms that are in the middle, and I end up with my product, 6x squared plus 19x plus 10. So what we are saying is that what we're going to see now is that we have an equivalence relationship, that the 3x plus 2 binomial times the 2x plus 5 binomial is equivalent to our final answer here, which was 6x squared plus 19x plus 10. Some of you may also have learned in algebra about foiling. Remember what FOIL stands for. First, outside, inside, last. So if I take my 3x plus 2 and I multiply it by my 2x plus 5, let's see what I end up with. So I've got 3x plus 2 times 2x plus 5. Okay, F stands for first, so I'm going to take the first term in each set of parentheses and multiply it. Sorry, I forgot my x there. 3x times 2x. Then I'm going to multiply the two outside terms, which are the 3x and the 5. And I apologize for the space here. We're going to do the I as the inside two terms, so I'm going to multiply 2 times 2x. And then I'm going to take the last term, which is the plus 2 and the plus 5, and I will multiply those as well. And so what we end up with when we do these 4 separate multiplications is the 6x squared. We get plus 15x, plus 4x, and plus 10. And I'm hoping that those terms sound familiar to you because, again, you're going to notice that those are exactly what we had when we did this the other way. We have 2 middle terms that we're going to combine, and we end up with 6x squared plus 19x plus 10. Same answer, double distributive property on the left, what we call FOIL, or first, outer, inner, last, on the right-hand side. Both are equivalent. Sometimes FOIL is a little quicker to do once you feel comfortable with the process. There's another reason, though, that we use double distributive property. If we look at exercise 3, we will see that we are now multiplying a binomial times a trinomial. If we were to try to do FOIL, the F, the O, the I, the L don't quite fit. So we're going to work with double distributive. Again, we have our 4x plus 3 binomial times trinomial, which is 2x squared minus 5x minus 3. So we are going to start as we did before. We're going to start with the 4x, and I'm going to multiply that 4x times the entire trinomial, 2x squared minus 5x minus 3. And again, if it's helpful to you, you may want to box in or highlight what that trinomial is. Then I'm going to take my plus 3 and multiply that by the entire trinomial that's in my red box there, 2x squared minus 5x minus 3. Now this is called double distributive property because at this point I am now going to do the distributive property on each of those. So I'm going to take my 4x and multiply it by each of these 3 terms. I will end up with 8x cubed minus 20x minus, that's minus 20x squared minus 12x. And then I will do my other distributive, my double, my second distributive, and I will get plus 6x squared minus 15x and a minus 9. If you go ahead and combine like terms at this point, I have a minus 20x squared, I'm going to have a plus 6x squared, and again be careful of your signs. I have a minus 12x that I will be able to combine with a minus 15x. And when I do that combining, I will end up with my polynomial. I will have 8x to the third. I will have minus 14x squared. I will have a minus 27x and a minus 9. And that will be my final answer. So now we're going to take a look, and we're going to substitute in part A our same product, but we're going to put in a value of 4 where x is. So I'm going to have 4 minus 2, and I'm going to multiply that by 2 times, and again I'm putting 4 in where the x is. I'm going to do the computation here. 4 minus 2 is 2, and I'm going to calculate my multiplication first. I'm going to have 8 minus 5. That's going to be 2 times 3, and I'm going to put my answer over here, and I'm going to box it in. So all I've done there is actually plug the value of 4 in where the x is. Now in part B of this example, notice the word trinomial. They want me to express this as a trinomial, which means they actually want me to multiply. So again, I can do double distributive. I can do the FOIL method. I'm going to choose right now just to quickly do the FOIL method. Again, double distributive is great, but I'm going to end up with a 2x squared. I'm going to end up with a minus, whoops, excuse me, let's go back on that one. I'm going to undo that, and we're going to have minus 5x, sorry, writing over the top of that, minus 4x, and I'm going to end up with a plus 10. Okay? So when I do that and I simplify it, I end up with 2x squared minus 9x plus 10. So now I've evaluated with the value of 4 in its original form. I've multiplied the trinomials, or excuse me, the binomials to get a trinomial. Now what I'm going to do in part C, it says evaluate the trinomials. So I'm going to take 2x squared minus 9x plus 10, and now I'm going to plug 4 in wherever I see x. So 2 times 4 squared minus 9 times 4 plus 10. Don't forget that the exponent only works with the 4 here, so I'm going to have 2 times 16 minus 36 plus 10. Continue with order of operations. I have a negative 4 plus a 10, and that is 6. Okay, the big thing we want to notice here is that whether I plugged 4 into the original problem and followed order of operations, or if I plugged 4 into the trinomial that I got after doing my multiplication, I get the same answer. And what that's proving to us is there's equivalence between those two expressions. Okay? Now, our last part here says, what is the value of the trinomial when x equals 2? Again, now they're asking us to take our 2x squared minus 9x plus 10. This time they're asking us to plug 2 in. I'm going to have 2 times 4 minus 18 plus 10. 8 minus 18 is negative 10 plus 10. I get 0. Okay, that was plugging 2 into the trinomial. Why does it make sense that that would be our answer? Well, let's take a look. If I go back to the original problem and I go back up here, as soon as I plug 2 in to the factor x minus 2, that becomes 2 minus 2, which we know is 0, and anything times 0 is going to give us an answer of 0. Let's take a look at our next example and go to exercise number 5, and you'll notice this time they're asking us to find the product of 3 binomials. Well, just like when we multiply regular numbers, if we had 3 numbers we were going to multiply, we actually only multiply 2 at a time. So what you're going to notice is that I am going to take the first 2 factors, the first 2 binomials, and I'm going to multiply those 2 together. So I have x minus 2 times x plus 4. I'm going to use double distributive this time. Again, be careful of your signs. And when I do my double distributive, I'm going to end up with x squared plus 4x minus 2x, watch your signs, minus 8. And when I combine those like terms, I'm squeezing this in here, I have x squared plus 2x minus 8. Okay, that's not our full answer, because if you'll notice, we had left out this last binomial. So what I'm going to do is I'm going to take the answer I got from the first two, the trinomial x squared plus 2x minus 8, and I'm going to multiply that by the x minus 7. FOIL won't work here. I don't have just a first, outer, inner, last. So what I'm going to do is I'm going to stick again to my double distributive, although in this case it's going to be triple distributive. I'm going to take my x squared times my x minus 7. I'm going to take my plus 2x times my x minus 7. And I'm going to take my minus 8 times my x minus 7. I'm going to have to distribute 3 different times. And when I do that, be very careful of your powers here. I'm going to have x to the third. I'm going to have minus 7x squared. I'm going to have a plus 2x squared and a minus 14x minus 8x plus 56. Careful of signs. And now I'm going to go and I'm going to group my like terms. So I've got some like terms here. I've got some like terms here that I'm going to combine. And I'm going to end up with x to the third minus 5x squared minus 22x plus 56 as my final answer to the multiplication of all 3. Okay? This is called a cubic polynomial because cube means to the third power, and you'll notice my answer was to the third power. Now they're asking us in part B, what 3 values will make the overall value of this 0? Now I guess I could plug things into x to the third minus 5x squared minus 22x plus 56 and do some trial and error and see, gee, I wonder if I'll get 0, but remember, I had 3 factors to begin with. Let's start here with the first one, x minus 2. Well, guess what? If x equals 2, that factor becomes 0, and that means all the things I'm multiplying together are going to equal 0. What if the x plus 4 had to be 0? Well, in that case, x would have to be negative 4. Okay, because negative 4 plus 4 would be 0, and I'd have some number times 0 times another number, but it really doesn't matter because when I multiply and any of the numbers are 0, I'm going to get 0. And so hopefully you can figure out the last one. If x is positive 7, I am going to end up with a 0 as one of those binomials, which means overall my product would be 0. And just to test one of these values, pick whichever one you want and give it a try. I'm going to plug in 2 where my x is. So I'd take my x minus 2 times my x plus 4 times my x minus 7. I'm going to plug in 2, so I'd have 2 minus 2 times 2 plus 4 times 2 minus 7, which of course is going to end up giving me a factor of 0, and it really doesn't matter what the other numbers turn out to be because that product in the end is going to end up being 0. That concludes our lesson for today. Take a look over your notes. Make sure you filled everything in and pause or replay any part of the video that you need to.